Hello, my fellow mathematician. Welcome to the study of complex maths. We are supposed to evaluate the integral of this function given here, where we are told z is inside this circle. So the first thing is you consider this function z minus 3 over z squared plus 4. So the first thing is you identify the poles. So we have two poles here. Poles, we have z1, which is equal to negative 2i, and also we have z2, which is equal to I2. Then after identifying the poles, we identify their order. Both z1 and z2, all of them are of order 1. After identifying their order, in our case they are of order 1, you check whether these poles are inside or outside this given circle. Now in our case, z1, which is equal to z plus I2, which is modulus, which is equivalent to negative 2i plus I2 modulus. This is equal to 0. Clearly, this kind of pole, it is inside the given circle. Then we come to z2, which is equal to z plus I2 modulus, which is equal to I2 plus I2 modulus, which is equal to modulus of I4. Clearly, this one is outside the given circle. So we are going to consider the residue. So we are going to get the residue 1, which is equal to limit as z1 tends to negative I2 of the function z plus I2 divided by z plus I2 multiplied by z minus I2 multiplying by z squared minus 3. In this case, you can see this part here will cancel, that part will cancel with that. So that now you are going to be left with limit as z1 tends to negative I2 of z squared minus 3 divided by z minus I2. So where you have z, you introduce it with negative I2. So this will be negative I2, you square that, minus 3 divided by I2 minus I2, which is equal to 2 squared is 4, negative squared is positive, negative 4 squared will give us negative. So here we will have negative. Note that we are making use of this I squared is equal to negative 1 from definition of complex number. Negative 2 squared will give you 4. So 4 times negative 1 will give you negative 4 minus 3, which will give you negative 7 divided by negative I2 minus I2 will give you minus I4. Cauchy residue theorem, my Cauchy residue theorem, integral of our given function, will be given by 2 pi r sum of residues, which is equal to 2 pi I multiplied by our residue. We have found them here to be as 7. There is I here, sorry, there is I there. Up here we have I. 7 over 4i. I and I will cancel. By 2, it is also going to cancel. And here we shall have 7 pi over 2. I and I have cancelled, meaning that our solution, this integral, the solution is 7 over 2 pi by making use of Cauchy residue theorem. By Cauchy residue theorem. So when we are going to evaluate a complex function like this to integrate, there are three main stages involved. So steps which you have employed there. Number one, you identify pose. You get to know the order of pose. Are they inside, on, or outside? Then given in boundary will be equal to 0. This is by Gaussat theorem. By Gaussat theorem, the sum of the poles outside the circle will be equal to 0. Then now you evaluate the sum of residues. Apply Cauchy. You apply Cauchy residue theorem. Cauchy residue theorem. So those are the steps we have followed here in evaluating this integral. So those simple steps method, that is what we are made to use here. By first of all identifying the pose, you get the order of the pose, find whether it is inside or outside the given circle, then evaluate the sum of the residues. From there now apply Cauchy residue theorem, and in our case, this is our result. Thanks so much for taking your time to study with me. Kindly let me hear from you any other approach which we could have employed to evaluate this given complex number. Also remember to subscribe to this channel so that you don't miss a single video which I upload for us every day. Bye bye, see you in the next video.